Good morning, students. Today we are going to start our next topic, that is the enthalpy change, that is represented with the symbol of del H. Change in enthalpy we can represent with the symbol uh, del H. Del for change and H for enthalpy. R we are using for reaction. Clear? In a chemical reaction, reactants are converted into the product and is represented by like this. Whenever we are writing any chemical equation, okay, we are writing reactants on left hand side and products on the right hand side in this manner. So that enthalpy change accompanying a reaction is called the reaction enthalpy. Clear? Means amount of energy in the form of heat we can see. ठीक है जो ਸਾਡੇ ਕੋਲੇ heat ਦੀ form ਚ energy change ਹੋ ਰਹੀ ਹੈ reaction ਦੇ ਵਿੱਚ, that is known as the reaction enthalpy. It can be increased or released. We can say reaction की exothermic भी हो सकती है ਜਾਂ ਫਿਰ endothermic भी हो सकती है, ਉਹਦੇ according ਆਪਣੇ ਕੋਲੇ enthalpy change vary करता है. ठीक है. So the enthalpy change of a chemical reaction is given by the symbol del R H. As already I have explained that del for change, H is the enthalpy, R we are using for reaction. Change in enthalpy for any reaction, del R H. How we can define this? It is equals to the sum of the enthalpies of the products minus sum of the enthalpies of the reactants. Clear? Means ਜਦੋਂ ਅਸੀਂ reactants ਲੈ ਰਹੇ ਹਾਂ, ठीक है, to perform any reaction, the total enthalpy of the reaction, and then we have to see the total enthalpy or heat released or gained by the products. After subtracting the enthalpy of product minus enthalpy of reactant, we will going to get the change in the enthalpy. Clear? Here the symbol sigma is used for summation. We have to study the combined effect of the enthalpies of both the reactants and products. This we are using for the summation, means how many products we have seen on right hand side. We have to take the summation of the enthalpy of all those. Clear? Where AI and BI are the stoichiometric coefficients of the products and reactants respectively in the balanced chemical equation. For example, for the reaction of methane with oxygen, that results in the formation of carbon dioxide and water molecule. This is the example of combustion reaction. ठीक है, combustion reactions ਤੁਸੀਂ 10th class ਤੋਂ study ਕਰਦੇ ਆ ਰਹੇ ਹੋ ਕਿ ਜਦੋਂ ਆਪਾਂ ਹਾਈਡਰੋਕਾਰਬਨਸ ਨੂੰ ਆਕਸੀਜਨ ਦੀ ਪ੍ਰੈਜ਼ੈਂਸ ਦੇ ਵਿੱਚ ਕੀ ਹੈ ਬਰਨ ਕਰਵਾਉਂਦੇ ਆ, combustion reaction occur ਹੁੰਦੀ ਹੈ. At that time ਸਾਡੇ ਕੋਲੇ ਮੇਜਰ ਪ੍ਰੋਡਕਟਸ ਕੀ ਹੁੰਦੇ ਆ, carbon dioxide gas with the release of the water molecules. So if we have to calculate enthalpy change for this reaction, we have to perform the same values in this equation. We can substitute enthalpy of product minus enthalpy of reactants. So on react product side, carbon dioxide and water. For this we can use enthalpy in its molar state, means molar enthalpy word use कर रहे हैं यहाँ से, ठीक है, for products as 2 moles or 2 molar enthalpy for the water we have to calculate, that is in liquid state, and then minus molar enthalpy of methane plus molar enthalpy of oxygen, that is 2 moles. HM is the molar enthalpy. Enthalpy change is a very useful quantity. Knowledge of this quantity is required when one needs to plan the heating or cooling required to maintain an industrial chemical reaction at constant temperature. It is also required to calculate temperature dependence of the equilibrium constants. Means how we can say that equilibrium constants will going to vary with the temperature. That only we can define if we know the exact order of heat change for that particular reaction. Clear? And next topic that we have to do is the enthalpy changes during the phase transformations. Phase transformation means change of state. Phase transformations as we can say that conversion of solid to liquid ਜਾਂ ਫਿਰ liquid to ਅਸੀਂ gas phase conversion ਲਿਖਦੇ ਹਾਂ ਜਾਂ ਫਿਰ solid to directly ਕਿ gas phase conversion sublimation ਦੀ ਜਿਹੜੀ reaction ਹੁੰਦੀ ਹੈ ਠੀਕ ਹੈ phase transformations also involve energy changes. Ice for example requires heat for melting. In case of ice, earlier when water is in its solid state, ठीक है, that is known as the ice. Ice में जो ਅਸੀਂ liquid form ਚ convert करना है, definitely amount of heat की ਸਾਨੂੰ system में supply करनी चाहिए so that it can melt. Normally, this melting takes place at constant pressure. Value of pressure is the constant, means we can say that atmospheric pressure use करना है अपन, and during the phase change, temperature remains constant. At the time of phase change, solid conversion to liquid, what we can see that temperature also remains constant. Here, enthalpy of a fusion is the enthalpy in a standard state. If water freezes, the process is reversed and equal amount of heat is given off to the surrounding. Clear? So this is the enthalpy change for the phase transformation. As we have already studied that for water to liquid conversion, enthalpy of fusion is equals to 6 kilojoule per mole. And the enthalpy change that accompanies melting of 1 mole of a solid substance in standard state is called standard enthalpy of a fusion or molar enthalpy of the fusion. Here means the amount of heat energy released or absorbed by the system for melting of 1 mole of a solid to its liquid state, that is known as the enthalpy of fusion or molar enthalpy of fusion. Melting of a solid is endothermic, so all enthalpies of fusions are always positive because water requires heat for the process of evaporation. Clear? At constant temperature, if its boiling point is Tb and at constant pressure, water from its liquid state is converted to a gaseous state with enthalpy of vaporization equals to 40.79 kilojoule per mole. That is the change in enthalpy for the vaporization process. Amount of heat required to vaporize 1 mole of a liquid at constant temperature under standard pressure is called its standard enthalpy of vaporization or molar enthalpy of vaporization, means amount of heat energy required to convert 1 mole of a liquid at constant temperature and at standard pressure to its vapor state, that is known as the molar enthalpy of vaporization. Clear? And then next, standard enthalpy of sublimation is the change in enthalpy when 1 mole of a solid substance sublimes at a constant temperature under standard pressure. Sublimes means directly converted from solid to a gas phase. Here, and next one is the enthalpy of formation. The standard enthalpy change for the formation of 1 mole of a compound from its elements in their most stable states, aggregates, also known as reference state, and is called standard molar enthalpy of formation. That is represented with the symbol del FH. And always you should keep in mind that enthalpy of formation for any system will going to remain negative because heat is released at the time of the combination. Here, and next topic is the Hess law of constant heat summation. According to the Hess law, we can say that this law states that the amount of heat evolved or absorbed in a process including a physical or a chemical change is the same whether the process takes place in one or several steps. Okay? For example, I am taking general reaction, a conversion of reactant A to product B. ठीक है. In this reaction, total amount of heat energy consumed is Q. That is the direct formation of product from A to B. But if I go for indirect preparation, ठीक है, for example, in 3 steps, if I am considering कि reaction साडी कोल 3 steps ਦੇ ਵਿੱਚ complete हो रही है, then first conversion of A to C, amount of heat energy use करनी है Q1 है, and then for C to B Q2, and then for B to capital B Q3, then total energy consumed in the reaction अपने को लिए equal आएगी the amount of heat energy consumed in each step. We have to take its summation, means the total amount of heat energy used in the product formation equals to the number of summation of the different heat energies that is used during the process. Clear? We can say that enthalpy change for reaction is equals to enthalpy change for first reaction, enthalpy change for second reaction, and enthalpy change for third reaction summation. Clear? And for example, graphite, when react with a limited amount of oxygen, it results in the formation of carbon monoxide gas. But we don't know the amount of enthalpy change for this reaction. How we can calculate the enthalpy change? We will going to take 2 general reactions. Let us study the preparation of carbon monoxide by indirect method. Consider the reactions. First reaction, graphite reacts with oxygen, results in the formation of carbon dioxide gas. Then change in enthalpy for this reaction is this one. Clear? And then second reaction, carbon monoxide reacts with limited amount of oxygen, results in the formation of carbon dioxide gas. Enthalpy change is given like that. That is minus 283, because formation reactions always going to show exothermic reactions. That's why मैं enthalpy change हमेशा negative sign के नाल ही represent की हुई है. Clear? So to get 1 mole of carbon monoxide on the right hand side, reverse this equation, second equation, carbon dioxide gas with the absorption of heat energy converted to carbon monoxide with a limited amount of oxygen. On adding equation first and second, means first equation this one and second that I have reversed. Okay, इन दोनों equations को जब मैं add कर रही हूँ, then I will going to get the general reaction, that is carbon in its that is allotropic form of carbon graphite in its solid state react with a limited amount of oxygen, result in the formation of carbon monoxide gas, and total enthalpy change for this reaction equal to the summation of enthalpy of the 2 reactions जो अपने, this is the first reaction and this is the second reaction जो अपन use कर रहे हैं. ठीक है, for this to define the overall enthalpy of the reaction. Clear? So this is the Hess law that states that total heat change or enthalpy change in general reaction is equals to the enthalpy summation of enthalpy change in different steps. Clear? So once revise this topic by yourself also. Thanks a lot.